So in this section, we'd like to derive the conservation of the energies. We start with the equation of the relative motions. Mu r2 dot equal minus g m sub 1 m sub 2 over r cube times r vectors. Then we consider the scalar product with the r dot. So this is r dot. Also this is r dot. Then you can find these equations. The left hand side of the equations can be expressed. This part is expressed this way, and the right hand side is gonna be expressed this ones. So this is a practice. So let's try to solve the practice 2.4. Demonstrate the following equations. So now I'd like to show you. Maybe it's better to start from the right hand side to go to the left hand side. So you consider derivative with respect to t. So but actually this is r dot. So we should use a chain rule. This is chain rule. And the 1 over 2 mu is a constant value. You can move the outside of the derivatives. Then chain rule. D r dot squares d r dot d r dot dt. So chain rule. We introduce a dr dot in these equations. So this derivative is actually 2r dot. This part is r2 dot. So it becomes mu r dot r2 dot. Then we got this equation. So sometimes if you have a difficulty derive the left hand side to the right hand side, you can start with the right hand side equation to derive the left hand side terms. So I proved these equations. First equation. And the second equation. So d g m sub 1 m sub 2 over r. So chain rules. And the g m sub 1 m sub 2 is a constant. G m sub 1 m sub 2 d dr 1 over r dr dt. We could make this calculation. This is gonna be minus 1 over r squares. Okay, and the r is a function of x, y, z because it's square root x squared plus y squared plus z squares. Right? To solve these terms, you have to take into account these factors. This is g m sub 1 m sub 2 over r squares. So this part is expressed use a chain rule. Round r, round x, dx, dt. Because x is a function, x, y, z is a function of t, plus round r, round y, dy, dt, plus round r, round z, dz, dt. You can express. And from this equation, you can calculate round r, round x is gonna be 1 over 2. It becomes square root x squared plus y squared plus z squared. And the derivative of with respect to x inside of this is a 2x. So it becomes x over r. So you can substitute minus g m sub 1 m sub 2 over r square. This is x over r. This is x dot. Also same calculations. Y over r y dot plus g over r g dot. Then it becomes minus g m sub 1 m sub 2 over r cube. This is expressed as scalar product. R dot, it's R dot. This is scalar product. Then we have proved the second equation, right? From the right hand side to the left hand side. Okay, so using these solutions, we could derive the conservation of energies. So we start with the equation of motion. On the left hand side, it becomes d dt 1 over 2 mu r dot square. And the right hand side is expressed d dt g m sub 1 m sub 2 over r. This is equal. Then we can move these terms in the right hand side to the left hand side, and you will get these equations. Then from this equation, actually derivative of this quantity is 0. So we could find that this quantity has to be the constant. This is equal to this quantity, it has to be the constant. As a constant value, we call that this is total energy. Total energy consists of the two terms. First terms correspond to the kinetic energies. This is kinetic energy. And the second terms correspond to the potential energy. Then from the equation of motions, by using the scalar product with r dot, we derived energy conservations. This is the end of this session.